Let us now discuss the rough banked road. Okay, let's consider a banked road that is rough, and let us say that it makes an angle theta, and let the coefficient of friction, static friction, be mu s. And what we know is that the mu s is less than, say, the angle of tan theta, which means that if the object was simply sitting here, it would slide down. Okay, and so what you're saying is that the object is going to move, and its speed, the fact that it's moving, is going to keep it at it's going to keep it on the incline so that it doesn't slide down the incline. Okay, once again, the radius of the circle is going to be r. I will go back to our same basic concept, okay, that if an object moves in a circle, it must have a centripetal acceleration, and hence must have, which should be directed towards the center of the circle. Okay, it's getting late right now, so I'm kind of messing up. But okay, so it must have a centripetal acceleration that's pointing towards the center of the circle. Let's draw a free body diagram. Okay, now here we also have friction, so keep this in mind. So first of all, we have gravity, which is mg, then we have Fn. Okay, now the tendency of this object, what we're going to do is we can find two things. We can find the minimum speed with which it must travel and the maximum speed that it must travel with. Okay, to find the minimum speed, since we know that the object is going to slide down the surface if it's just simply sitting at rest, okay, what we know is that the force of friction is pointing up the incline, okay, because otherwise it's going to slide down the incline. Okay, so the force of friction has to be pointing up the incline. Now again, understand that it's not sliding up or down, it's going into the paper. Okay, it's going into the plane of the paper. The object is not sliding up or down, so please keep that in mind. So the force of friction is going to point there, and to find the minimum force, okay, we'll take the maximum force of friction that we have, which is going to be equal to mu s times Fn. Of course, we do not know Fn in the problem yet, and the result of these three beautiful things is going to be mv square over r. Okay, so the what am I saying? Oh yeah, so the centripetal thing is mv square over r. Now, since we know the angle theta, let us break all the forces into components. We know that we need to break mu s Fn and Fn into components because we would like to break forces into components that are not along the acceleration or perpendicular to it. So Fn makes an angle theta with the vertical, and mu s Fn makes an angle theta with the horizontal. So the components of those are, for mu s Fn, the horizontal component is going to be mu s times Fn times cosine theta, and the vertical component is going to be mu s times Fn times sine theta. For Fn, on the other hand, the vertical component will be Fn cosine theta, and the horizontal one will be Fn sine theta. Great. Hope you can read through this mess. And what we have now, our equations are going to be Fn cosine theta plus mu s Fn sine theta equals mg. And then what we also have is Fn sine theta minus mu s Fn cosine theta equals mv square over r. So this is the minimum speed possible. Okay, so the first equation gives us Fn. Fn equals mg over cosine theta plus mu s sine theta. Okay, I can factor the Fn out, and then whatever is left I divide both sides by that. Okay, the second equation gives us this Fn times sine theta minus mu s cosine theta equals mv square over r. And now I can substitute for Fn. So Fn is mg. Okay, it is mg divided by cosine theta plus mu s sine theta equals mv squared over r. Great. This gives me an expression for v. V is equal to square root rg times sine theta minus mu s cosine theta divided by cosine theta plus mu s sine theta. Awesome. So this is my minimum speed. This is the minimum speed with which it must travel. Now there is a maximum speed also, and for the maximum speed, all we need to do is realize that the force of friction will be pointing down the incline. Okay, so this is something that you can do as an exercise. Repeat the problem, and to find the maximum speed, realize that the force of friction will be now pointing, because as your speed increases, okay, at some point now you're going to slide up the incline, which means the force of friction must be pointing down the incline. Great. So this gives us the value. Now here's a very quick check here. Okay, if the value of mu s is 0, which means if mu s is frictionless, okay, then you see that we end up getting rg times tangent of theta, which is the value from the previous problem. Okay, so this tells us that the expression is actually correct and makes sense. Okay, so simple calculation, stuff to do, and that is it.